Alright, hello folks! Welcome back. I'm very excited to be with you again here in Solidworks. For today's video, we're going to do something very interesting. We're going to learn how to do finite element analysis and how to use topology optimization to optimize the shape of some piece that you need to find the boundary conditions of. For instance, in here we have this Y-shaped bracket that I just designed. Let me show you real quick some of the parameters in here. Yeah, so nothing extraordinary. You can do something like this by yourselves. And what we're gonna do, we're gonna subject this to a couple of loads, and we'll see whether we can make this shape a little bit more optimal. And what do I mean by optimal? Well, probably just reducing the mass that this has, because less mass generally in the industrial world means less money that has to be spent. In order to do that, we'll go here to where it says Solidworks add-ins, and we'll click here where it says simulations. So let's give it a second. Usually takes a while. So in here, this new tab appears. So we're gonna click there, and we'll click in new study. Oh, where is it? Boy, well, it's moving a lot. All right, new study. With this new study, we're going to do a static analysis first. So let's first see what is that we want to do. So let's call it our test. That's how it's going to be called. It's going to be a study. Then we'll later use this guy, but for now I'm going to stay with static. So we'll click OK. And here's a bunch of things that will appear. So of course, this is the model that we'll be using. Then I'm going to right click in here and I'm going to apply and edit material. So that's the first thing that we'll do. So yeah, I had already predetermined from earlier. I was in here, so I set the material of this piece to be some sort of steel. Make sure that the material that you're using satisfies the values that you want. Because even though there's many different types of steel, they don't usually have the same, elastic modulus or Poisson's ratio. So I'm just gonna close in there. Now, well, we're not using connections. We're gonna fix. So we need to use. I'm gonna use a fixed geometry. So what I'm gonna do? Let me just hold here the view. Modify. Oh no, I don't want to pan. Rotate. I'm gonna fix. Oh no, I don't. You see those two holes in here? I'm gonna fix them. So how do I do that? That is a great question. Well, my mouse has just died. Give me just a second. All right, here we go again. So I'm gonna first click escape. There we go. So I'm gonna fix the inside of that surface. I'm gonna fix. Oh no, I'm still in the. There we go. I can fix that face, and I can fix that face, and then well, you can choose whether it's a fixed geometry, it's a roller, or it's a I think. Roller might be better. Like it depends, because otherwise I'm allowing it to roll. I think I'm just gonna make it fixed geometry just for simplicity. There's so many different boundary conditions one could play around with, but this will require learning the theory of finite elements and taking some course in mechanics of solids. But that goes beyond the scope of this video. So now we're going to apply a load. So let's say that we're going to apply a force. And the way we're going to apply it again, we'll choose, oh, no, I don't want that face. I want the inside. So here, let's suppose that the force we want to apply it towards the left in this direction, right? Let's see whether we can do that. So I'm gonna use, oh, but I should have drawn like some sort of direction, unless I can specify it like this. Let's see. Like 20. Or the normal over that. Non-uniform distribution. No. Well, otherwise it's gonna be applied towards there. But let's see. Let's see if I apply 10 with the arrows. Actually, it could be a long display if you want. There we go. Alright, that should work. We're using that plane. As you can see, the force being applied like that, but we're gonna reverse the direction. Alright, so it's gonna be, we're gonna apply 20 newtons in that direction along that hole. We might increase it to 100, because why not? And let's click OK. We'll do the same thing over here. Let's apply a force. Force in here. Again, that surface. We're going to select the direction. We're going to select along this plane. And we'll apply again 100 newtons in the opposite direction. Click OK. So there's, of course, many different things that one can do. Again, the more information that you would provide the simulation, the more accurate it's going to be. And the better the results are going to be for you to interpret them. Because, you know, simulations are just simulations. And reality is just filled with all sort of different scenarios that one, you know, you cannot all simulate all of them. Then we can go here to mesh. So we're going to divide this piece into very, very little pieces in which many different stress and strain calculations will be performed. And as you could expect, the finer this mesh, the more elements that we're going to have, and the more accurate this result is going to be. And here I can just click in here, create mesh. I can say I want it, you know, towards the finer side. Let's see what other parameters do we have. Oh, we could actually see how big we want the elements to be. I'm just going to use this slider for simplicity. See another advantage. Let's see. Okay. Wait a moment. We should be able to see it in here. All right, that looks pretty reasonable to me. Again, feel free to do it however you want. And now we can simply click on. All right, and actually up there, let's run this study. Let's run this study and see what this does. I'm not sure whether this is working or not. Oh, all right, let's give it a moment. All right, so now the simulation is done, and thankfully it kind of did what we wanted to do, or more or less what we expected it to happen. Essentially, in these orange lines that you can see in there, they denote the original contour of the shape. And now this colored shape in here denotes the deformed version of the shape, even though this is of course very amplified. We are just, you know, for the purposes of our visualization, we're just amplifying the actual deformation. But well, it did work. This moved right, that moved left, and we can see the stress in here. Some things to note that are very important is that the yield strength, which is the strength at which this material, which was actually the AISI steel, would break. In this case, well, that is about 200 megapascals. And as you can see in here from the Mises stress in here, we are well below that, so we are quite alright. You can see that stress, the highest stress would be around this area, so this is something that if we were design engineers would pay a lot more attention and see how can we minimize the stress going on here. But more importantly, something that you can see is that a lot of this shape is blue, and blue is the lower stress. Look how low that is compared to that red number in there. It's about 4 orders of magnitude below it. So that means that a lot of this material could probably be eliminated if we wanted to. Let's take a look at the displacement curves in here. Let's see, give it a moment. Solidworks is taking quite a while today to function. You can see the little timestamp in there. All right, here we go. Well, you can see that it barely deflects. So like that zero in there, that is basically 0, that number in there, so it just didn't deflect at all. While this red, it shows the area that has deflected the most. And again, to give you an idea of the magnitude of how, amplified this deformation is, that is very tiny. That is 2 orders of magnitude less than 1 millimeter. I should notice that if you right click in here, you can just, there's all sort of different parameters that what you could, for instance, animate this thing. So I can be like, all right, let's see. Here the speed. Let's see. Oh, screen the frame. All right. So it shows you how this thing is actually changing in shape a little bit slowly. You can see that happening. If you wanted like a cool video that shows the progression of that thing, you can also right click in here and just change like the actual like colors, the bar, the precision with which you want to see this, whether you want scientific notation or you just want exponential notation, so on and so forth. But I'm gonna skip all of those things. Please feel free to look them up, because I want to go into the interesting stuff as soon as this stops loading, which is the topology optimization, which is, well, we know from the, not from this one, from the previous diagram, that there were a lot of blue areas that had very low stress, which means that we could probably eliminate them. They are not necessary in our design. So we will let Solidworks actually determine how to do that. So let's give it a moment. Alright folks, we are back again in here. It turns out that Solidworks crashed, so I had to redo the simulation all over again. But it's essentially the same thing, what I have just done here, the same numbers that we had before. I should say that I just realized that we can see the deformation scale in there, which is 1102.5, which is a lot, and it's very representative of the numbers that we've seen in there. So as you can see, we got all of these blue regions, as I was mentioning earlier. We want to see whether we can, remove them or make something more optimal out of here. So in order to do that, we want to do a topology optimization. How do we do a topology optimization? It's very easy. We can click in here in New Study. Over here, we can say, well, actually, New Study. We can click in Topology. Where is our friend Topology? Over there. We have to redo everything again, so we need to, establish all of these boundary conditions again, the fixtures, the forces. Or instead, if we have already done our study and we have checked that our piece actually does what we wanted to do and it behaves in a way, that is quite reasonable, we can right click in our study and click in where it says copy study. We click here Topology and we go OK. So you see all of these things are imported into our topology study, so it saves us time. So here you can see that we have the fixtures, we have the 2 forces, and we have 2 additional features in this feature tree, which is the goals and the manufacturing controls. I'm going to right click in goals and you see we got 3 different options that one can choose from. So let's begin with this one. Let's explore the first option, which is best stiffness. So what does this thing do? Essentially, we can say, alright, we got a mass constraint. And we can say we want to reduce the mass of this piece by 30%. But at the same time, we don't want the piece to jeopardize its structural rigidity, for instance, right? We still want all of these boundary conditions to still be satisfied. So we could say, alright, let's reduce it by 50%. So the current mass given the material that we have chosen is 0.25 kilos, and it will end up being 0.128 kilos in here. This is one option. We can look at displacement. And what does displacement do if we want to do a displacement one? We have already seen the displacement field, that it was maximum over here these boundaries. So we can either specify a factor or a value of the maximum displacement we want, and we can say, alright, I actually want to, optimize this shape such that we will never exceed this. This is our constraint value in here. We can say, alright, this is actually even more restrictive. I want this displacement to be at most, I don't know, 1 millimeter. So let's optimize our shape from there. But we will not use displacement constraints. We just want to focus for now in the mass. Now, I should mention here that, well, it's gonna like the shape of this thing is going to change given this parameter. We also have frequency, but frequency is a little bit more advanced given the scope, or safety factor. And this one is one that I like a lot. Let's say we want to specify a value. Let's see, we got stress constraint. Or you can say, for instance, stress constraint is, or I don't want the stress to go beyond this number. Or you could just simply say factor of safety. For those who do not know what a factor of safety is, this is the ratio between the design stress over the yield stress. So what does this mean? That we can say, right, I want this piece. This piece would normally break. Actually, I believe it's the other way around, because this piece would normally break at the yield stress, which, for instance, for steel, we already know that is around 200 megapascals. However, I want this piece to be operating at half of that, at 100 megapascals, which means that we have a factor of safety of 2 in that case, because we just want to stay well beyond the region in which the stress of this piece would be large enough to actually break this piece. But we won't use this for now. We're going to stay with just that boundary condition. Let's take a look at the other ones. Well, we have, let's see, I believe it's just the same thing in here that we were just looking at before. Now we go manufacturing controls, because we can actually provide a bit more information to our Solidworks in here to tell them, all right, how are we actually making this piece? So we can, first things first, let's add a preserved region. And what do I mean? Yeah, all right, no worries. What is a preserved region? So essentially, as you can see, we have these holes, and those holes are, for instance, places where some bars will go in whichever assembly this is going to be used in, and we want these holes to actually stay. These things, all of this Y shape can change, but these holes must remain. So we can, click in here, we can click in there, we can click in here, we can click in there. We can say, we can actually tell them how much of an area that we want. We can change the units to inches and say 0.25 of that area. Let's use geometry preview. Alright, so we see these two circles. Maybe we might want to reduce that to 0.2. Yeah, so they are well within this area. So this region must be preserved. That is essentially what's happening. So we're going to click OK. If you wanted, what we could do as well, let me just hit OK in here. We can add another preserved region. Okay, I'm going to choose, there we go, the boss extrude, so just like this boundary in here. Let me see if it actually selected. Give me one more. Let's, if I click like 0.1, the geometry preview. Oh, it only, so we would need to select all of these faces. We need to go all around and around, so let's do that real quick. For instance, let's say that you actually need the shape of this thing to stay the same. You don't want at least the boundary of the shape to some extent. Let's continue modifying our views. Boom, 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 boom. And actually that one. We can click here, okay, a 0.1 inch depth of that. View, well, let's go back to our view from above. We got our shape, got everything okay. So let's see what else can we do. We can specify thickness. And what is the thickness really in here? Telling you, let's suppose that we're gonna machine this in a 2.5 axis CNC machine. And you know that, what is the minimum thickness? So it's actually telling us to take a look at here. We have an end mill, and the thickness of an end mill generally will be one of the limiting factors in how how big of diameter can we have there. So I can say that the minimum thickness that we have is 0.1. Let's see, like that. That is when we have our end mill making a pass around this. If we're machining this piece, that's the minimum diameter that we can use. Then another thing that we can do, let's see what else. We can specify the mold, because besides, this could be a piece that is generally made using additive manufacturing, in which case we don't need to specify the thickness, but we can also, just make this thing out of a mold. In order to do that, we can select pull direction. So from the tutorials I've seen before, generally the best practice would be to make it symmetrical. So it's mid-plane. So I can choose that little edge over there, and like these two arrows appear. Just click OK. It's just giving more flexibility to our final design. What else do we have? Let's specify a symmetry plane, but that is not necessary. And again, we can go here to mesh. So we can go here to create mesh. We can make a tiny bit on the finer side. Let's click OK. Let's generate that mesh really quickly. It's going to be similar to what we saw a little bit earlier. Also, give me a moment. Hopefully, Solidworks won't crash right now, although I'm afraid it might, since it's not doing anything right now. There we go. Thank God, this is fine. So now all we are left to do is run this study, which will take a little while. So let's see whether we can do that. Can we do that now? Should allow us to do that. There we go. All right, so let's run the study. And I'm gonna click in there, and I'll probably pause the video here, and I'll come back once the study is done. All right, hi folks again. Well, it actually crashed again. I apologize for that. And after literally about an hour and so, it only did 5 iterations of what we wanted to do. And I also had to change a couple of things in here. I eliminated the minimum thickness, and the mass constraint, I made it actually 25% other than the 50 that we originally intended to, because I thought that was one of the reasons why it wouldn't start. But well, we ended up with this, which is pretty representative of what we wanted to have in the end. And notice a couple of things in here. First, the yellow, as you can see here, is the regions that we have to keep. And it's not surprising that we see this, because we had already stated at the beginning that we wanted to keep this 0.1 inch boundary around this whole shape. And then, we have those 2 holes in there that we wanted to have as preserved areas. If we double click over here in material mass, you can see that, well, that is very interesting. Calculate element mass. Well, you can move that slider in there. Just give me one moment. My mouse has just, there we go. Oh, I use this one here, so we can just move it like that. And you can see how this guy over here will change a little bit. Just give it one moment. So you see it begins to go down. This is the percentage of the original mass. So let's bring it all the way over here. See how it's slowly going down over there. So on and so forth. There we go. We got that design. So I guess, well, that would be a little bit too much. So I might want to leave it around there. Yeah, that seems reasonable. We can calculate a smooth mesh in here, so we can click over here. See what this is. Oh, that is pretty good. Let's see how that changes now. Yeah, that is pretty good. This is more or less a pretty good design. I'm just gonna exit this area where we're back to where we were at the beginning. So we can right click in here, and there's a couple of things that we can do. And the most important one is that we want to probably export the mesh in here towards our model, so that we can continue, doing more modifications in our file and actually test again what we have done. So we can click in here. Where is it? Export smooth mesh. Let's see in here, new configuration. Yeah, that seems okay. All right, let's go. Just give it a moment. And you'll see that the colors that we have before will be overlapped in our original shape. So let's see whether that will be happening or not. But actually, instead of actually exporting the smooth mesh, what we can do is something else. We can again double click in here, material mesh. This is again how this will look like when we just move the slider in there. We'll go here to settings and we're gonna superimpose, because that's gonna make our life easier. We'll choose a single color. We'll choose a color that is different from gray, so we can go for green, for instance, and just give it a moment. And then we can click in here. Okay, there we go. So now we can go back to editing our model and we can just carve out those areas. So at least we have an indication of where we can remove mass from this thing. So let's go ahead and do that. Go back to model. Oh, hold on a moment. There we go. Here we go. All right. So we're still at the topology study. We don't really want to go back to model. So let's go here to sketch. Let's just sketch over here. To make our life simpler, we don't want to make a sweep. Let's sketch, and we want to do a center line. Oh, yeah, and here. All right. You make use of this plane of symmetry. There we go. I apologize that I won't probably define my sketches that much. Boom. Oh, since I'll be using my spline tool, this is just like easier to do this rather than just using rectangles. And it will probably look quite okay, I hope. I'm just gonna leave it there, and I'll probably finish up that with a nice straight line. We can probably fill it on the ground over there. Let's go ahead and do that. In here, choose that point, and we can choose that point. Oh, did we? Just give me a moment. And boom. There we go. Yeah, we're gonna leave it at 0.1. Okay. Let's close that, and then see whether we can do something over here. Well, we can just do a nice rectangle. Comes all the way like that. Oh, there we go. Escape, and now let's fill it again. This guy and that guy. Now what we're gonna do is let's leave this. Let's do a mirroring of this and that. Oh, it's taking a while today, Solidworks to work. There we go. Of course, we're gonna mirror about some line over here. Let's go ahead and do that, and now we can just extrude cut all of these areas that we have created by 0.25, no quarter inch. So now we can let's see if we can go here to simulation and do a study. Let's do a new study. All right, so here you can see the new optimal shape. So why do we want to do a new study? Of course, to check that everything is okay. So we'll click here, yeah, static one, why not? Let's do usual fixtures. We could have probably copied the boundary conditions that we had, but you know, just it's not the end of the world to do them again so that we get extra practice. And here, external loads, force, here, because really this is just one final step to confirm that what we have done is actually correct, right? That we have removed mass, but it's still working correctly. So let's click in here 100 newtons. See which direction it's pointing in. That is perfect. Do the same thing over here, another external load. Select direction. I'm going to click over here. Yeah, yes, there we go. And now let's put 100 again. We're going to reverse direction. That is perfect. And now we're just going to click in mesh and run, because that is, in my experience today, the feature is giving us the best results. So we're doing that. Let's leave it do its stuff, and let's see what is the stress, you know, plots that we'll have on our piece. So I might pause the video in here. All right, the results are in. As you can see, it's not very different from what we had before. So essentially, it's mostly blue with a little bit of green, which is indicating that, well, there is an increase in stress, particularly in these areas. I'm going to tell you why. There's a couple of reasons for that. Notice also a little bit of red over there, and that's because we have a stress concentration, which generally comes around when we have a sudden change in geometry in our piece, which is something that is essentially occurring when we're using these splines or fillets around here. So we have to be very careful when we're doing that. Nonetheless, we're still well below the yield strength of our piece. We are saving a lot of mass, about 50%. And this is just a good example of how to use topology optimization in Solidworks. I had intended to also do another exercise in here, because this is just an imaginary piece in here, but I wanted to show you something that General Electric did a while ago. There we go. So they had introduced this bracket that you can see in here. Let's go back to Google Pictures. Well, you can see it here as well. And they said, all right, let's actually try and optimize that design. Can you make it better? And using topology optimization, folks have come up with like designs like that one that you can see there, or this one, that one. You can Google it like that, and it will give you good results. And actually works, because, you know, every gram that you can save in the aerospace industry is just a lot of fuel consumption that you can save as well. And for us, I wanted to try doing another exercise for an aileron hinge. Let's see whether it opens. It's taking a while. There we go. Like this one design in here. And in fact, we can go back to SolidWorks. Let me just see real quick whether I can open it. Go here to File, Open Recent, and I pre-designed an aileron bracket. Let's go here. But since it's taking a long while in order to run these simulations today for some reason, I'm just going to skip doing them in SolidWorks, and we're going to bring these two guys into Fusion 360. Because the purpose of today's video is actually to compare how does actually SolidWorks compare to Fusion 360. So let's go ahead and do that. I'll pause the video now in here. All right, welcome to Fusion. This is the first time that we are using Fusion in here in YouTube. So in here, this is just simply another CAD software, very similar to SolidWorks. It has very similar functionalities, as you can see in here, but we won't focus on those today. Today, what I just have done is I went here, you see like these little like squares in here. Just clicked in there. I created a new project, and then I uploaded these new files, and I uploaded the Solidworks files that we were using. I'm just gonna right click in here, and we're just gonna open that document. And we're just gonna bring this into the Fusion interface. So no need to design anything. We just got it in here. A couple of things that we can do in Fusion, in SolidWorks, I usually go here to View and then Modify to Pan, and here I can just like click down there and orbit. So it's a little bit simpler. It is a much simpler interface in my opinion. I like it a lot. It's actually only been recently that I've been introduced to Fusion 360, and I like it a lot. It definitely doesn't have many of the complex functionalities that SolidWorks does have, but it's quite okay. And now we're just gonna click on where it says design. It's very simple, and we're gonna go here to simulation, and we're gonna repeat one of those, literally the same simulation that we just have done. Give it a moment. Yeah, we're gonna do a static simulation in here. Then we're gonna use this guy, but for now we're gonna leave it at static stress. We're gonna create a study. I should say that Fusion simulation. Yeah, no worries. Confirm. I should say that Fusion 360 is actually free for students if you're enrolled in a university. And many of these things, besides designing like simulations or generative design, which is one of the most cool features that the software comes with, they require cloud credits, which are, I believe one cloud credit equates to $1 US. So it's not very cheap. So running these simulations is not cheap. Nonetheless, as students, we get unlimited cloud credits, as long as we're not doing research with this. So yeah, let's actually get started. So we're gonna do, we got our new study. Oh yeah, we are actually ready in our study. We're gonna first specify the material of this guy. Oh, that is interesting. Maybe let's go into properties. Oh, we actually have it actually did import the material we're using from Solidworks, so that's pretty convenient. Let's define our constraints. So just click in there. So what I'm gonna do, you don't have, as in SolidWorks, the feature, it's more or less like that. So we got these two faces in there, and I'm just gonna leave it at fixed. You can choose where it's spin, frictionless, but we're using fixed, and I'm gonna leave it like that. Give me one moment, that my mouse has just died. There we go, back again. Okay. We got our constraints. We can apply our loads. So let's select our face in here, boom, like that. And you can see something I love about Fusion is that you can use this arrow in there and you can go like boom. You can just rotate that and you can just select the direction in which you want to apply that force. There we go. Once more, so we can leave it at 90 degrees. That's where we want it to be. It is on that face. It's not exactly distributed throughout the face. The arrow is just appearing at that top area over there. But and now let's actually specify how big of a force we have in here. So it was 100 newtons, if I remember correctly. Changing, yes, it is a newton that we got in there. We can actually have normal. Oh, interesting. We don't want to flip the direction. I think that is okay. Yeah, we'll just leave it at 90 degrees that we had it there. Boom, okay. Let's do the same thing, but on the other side, we need to apply our 100 newtons. Let's go ahead and do that real quick. Loads, this face, boom. Oh, let's zoom out for a moment. There we go, 90 degrees. Yeah, let's make this guy bigger. Is it possible? Bigger? My mouse is dying. In a moment. There we go. 90 degrees, and here we go, 100 newtons. Perfect. All right. I believe we are basically we got our loads, our constraints. Maybe we could actually right click in here. Let's generate a mesh. Let's see what this gives us. By the way, this is, you can notice this is being done in Mac, while Solidworks I was using a remote desktop to use it in Windows. That's why it was probably working a little bit not that nice. Let's see whether we can actually refine this mesh real quick. I don't want to model view. Mesh. Yeah, let's take a look at mesh settings. Average element size. Let's click here on OK, and let's generate the mesh once more. Let's see whether they actually look smaller. They maybe, I'm not sure. Anyways, before we actually solve anything, we're gonna do a pre-check to see whether this is all the information required. All right, so we can actually run our study, which is a good thing. We got everything we need, so now we can, yeah, we can solve. Yeah, good. Solve one study, and here we can see the job status. So it's actually being solved not in my computer itself, it's being solved on the cloud. Where's the cloud? I have no idea. But it's pretty cool because it might take, at least you can see here that it is already much quicker than what it was in SolidWorks before. So let's give it a moment or two until this stops running, and we just want to first do an initial check to get ourselves acquainted with the interface that we got here in Fusion 360, and then we're actually going to do the optimization, the topology optimization here. So I'll stop the video here and I'll be back in a moment. Alright, so it's actually done, thankfully, and well, let's take a look at what is it exactly that we got ourselves in here. So actual minimum factor of safety, that's pretty good. We got a minimum factor of safety 7.35. If you remember, that was the ratio between, we got the maximum yield stress over the design stress at which this is going to be operating. Just close in there. Let's see what else can we, let's take a look at the stress. All right, interesting, very similar to what we got before. Again, there was a stress concentration in there. It's showing us that this is in megapascals. I see. I believe the numbers are a little bit different from what we had in SolidWorks a while back. But it's still, we are seeing the blue regions, at least the regions where there's not much stress. It's quite similar to what we had before. Let's take a look at displacement. The same plot for displacement, at least the colorful part. We just leave it in stress in here. There's a different, maybe you could probably, interesting. You can actually see. You can modify a couple of things in here. So now let's see where a little simulation here. Let me try and see whether we can create a new simulation from here. So yeah, let's finish results. Just leave it like that. I'm gonna right click and study. I'm gonna clone study from here. I'm gonna see if I can go here to settings. No, because I want to actually, let me see if I can do it as in SolidWorks, where I could begin the topology optimization out from here. But it's not allowing us to do that, is it? Yeah, we can just create a new study. Let's just go here, back here. We're going to do shape optimization, create a study. And we're going to just do the exact same things as before. Maybe this one I'm going to eliminate it because that is just a clone. But what we're going to do is study materials. Let's just make sure, same as in model, we got the same material as before. Shape optimization settings. Well, we'll take a look at that in a moment. Let's first fix the constraints that we had before. So 1, 2, gorgeous. Then the loads, we're gonna have the same loads that we had before. Let's move our arrow 90 degrees and then 100 newtons. Okay, let's do the same thing over here. Oh, no. Cancel. Loads. Let's move this guy around. Once my mouse comes to power. Yeah, the connection is lost. There we go. Yeah, let's move this guy. Boom. How many degrees is that? No, that is 80. 90. There we go. Let's go here 100. I got the same load studies. And now let's take a look at shape optimization. Let's just see. All right, target mass. So let's double click in here. Or let's, yeah. So we want the target mass of 30% of the original one. All right, we can leave it like that. We can maximize the stiffness. Yeah, that is okay. Okay, let me see. Let me just look at this again. Can we add? No. What else could we add? No, we don't have anything else that we could add in here. Oh, yeah, we are kind of using the same load case as we had. Well, we can actually create a couple of different load cases. For instance, this is the one that I have just created here with like the two forces. But what if I go here and create a clone the load case? There we go. And now I'm gonna change. Let me just edit this guy real quick. Let's say I'm gonna pull. It's gonna be subjected to like two different locates. One when it's pulled from side, one where it's pulled like upwards. Oh, and we're keeping the same 100 newtons force. I'm just gonna leave that at 20 degrees. Let me just edit this force as well. So this is quite good. You can begin to notice difference in functionalities with Solidworks, where in here you have a little more flexibility on what is that you're optimizing, even though, well, I should correct myself. The optimization settings are a little bit more limited, but when it comes to concerning load cases, this is more reasonable. We can edit this guy. Scale mesh side absolute side. Oh, I don't know. Let's take a look at. We have advanced. See, okay. Well, what happens if I generate mesh? How big of a mesh would this be? Yeah, I believe 1 millimeter might be too small. I'm just gonna cancel it. Yeah. I'm gonna mesh settings. Let's make it. Just leave it around there, and then it's generate mesh. Let's see how small will this be. All right. Quite similar to what we had before, maybe a little bit finer. And now let's just make sure that, let's do a pre-check. All right, we got all the information that we need, so we can solve. All right, solve one study. That is exactly what we're gonna do. And as you can see, it's gonna be five cloud credits. I'm gonna solve our study. Click in there, and this is gonna take a little while. Maybe we can wait in here because the other one didn't take as long as I thought. So that is already a positive for fusion. So let's see how this looks like. And if this works well, we'll do the aileron bracket too. So I'm already liking this interface a lot better. In fact, I'm going to tell you right away that I would rather perhaps use Fusion for doing these sort of tasks. Maybe Solidworks to design the initial part, but maybe Fusion for running these sort of shape optimizations and then getting an idea of where is it that I need to modify my part and what not. So yeah, maybe I'll cut the video here and I'll be back in a. Oh, actually that is good. So let's click in here, close, and let's move. All right, very interesting how this is looking like. These are our parts. let's see. There we go. No, I don't want to. And so here, like just like we did before, we can modify how much of the part that we want to look at. Well, this is very interesting. So I'm beginning to notice right away a couple of things that are rather interesting. First things first, you know, while the design looks a little bit nicer with like these hollow areas, I would say that, well, they are not connected. That is problematic because otherwise we wouldn't have our part. Let's see whether, what can we do? Yeah, we can show in max. Interesting. But I'm not sure what is it, is the min and max off. I don't want to display the mesh. Compare no, results to. Hey, let's take a look at animate in here. Oh, so it's actually telling you iteration by iteration. What has been? Wow, that's very interesting. Let's see whether we can do 20. Oh. Oh no, there we go. Very interesting. It's barely changing anything after number 10, I would say. Alright, so this is where the fun begins to happen. So we got the shape. This is what we got. Of course, this is an indication of what we want. But we can go here to where it says promote. And what does promote do? It will send more or less this contour, these color contours, into SolidWorks. No, not into SolidWorks, I mean into the Fusion CAD interface, where we'll be able to modify a little bit these areas, just extrude cut, remove them, and then we'll just rerun the simulation and see what it gives us. Yeah, so existing simulation, no. Yeah, let's see, let's go, okay. Let's see, I'm not sure, so let's give it an okay. And here, good. Oh, all right, so that is exactly what I wanted to see. So this would be the optimized shape. So now I'm gonna do a sketch on the upper part. So in the light gray color that we can see in here in that contour, that is the original shape that we had, and pink the optimized one. So let's get started with some fun stuff. To do that, let me create a sketch, and I'm gonna choose that plane when it's allowed. Boom. And only if my mouse worked. Let's give me some trouble. There we go. Right, boom. There we go. So let's say we're gonna do like a rectangle, and it's just like there, then a couple of lines. Of course, this is just a rough guideline of what I want to do. Yeah, I'm gonna leave it like this. Boom. I'll probably mirror most of these guys in a moment. So we got a couple of constraints here, so I can go like this, and then say, and select these two lines. So clicking on command and be like, oh, so we can make them equal. Boom. And I can make, oh, no. Now I can say, I might wanna, I'll fix this line in there. Maybe, where's, we can dimension that. Oh, no, I just want to dimension this to be 5. Let's see. That is interesting. Maybe 3. That is much better. We can dimension this and that to be oh, I see. Now maybe I'll eliminate that line. There we go. We're gonna probably make this distance. Let's see whether. Huh, interesting. Yeah, let's see whether we can make some sort of midpoint. I'm not sure how this works. Maybe I'll just use a good old line like that. There we go. All right. I'm just gonna leave that line in there. I'm gonna say, let's make that be 4. Let's make that be 8. That's right there in the middle. We'll do the exact same thing with this guy. Oh. And that 1.5. So that it is symmetrical. Well, I'm gonna do it like that. Boom, boom. The same thing with this rectangle over here. We'll make that 18. We'll make that 18 as well. And we can. One thing I noticed about Fusion as well is that it doesn't have construction lines, so that is a little bit annoying. That is okay. I might leave those guys undefined, but I'll do a couple of fillets. Here, boom, like that. Oh no, I don't wanna. Let's make it 5. There we go. Now we'll do the same thing with these guys. There we go. I like that. I might do the same thing with these guys. Oh, I didn't select the fillet tool. Maybe we'll use 2. Again. We'll do the same thing over here. Alright, now we got this thing. We might want to mirror this around. So where is our friend the mirroring tool? I believe it's here. Create mirror. Boom. Let's see. Yeah, select objects. Boom, like that. Select mirror line. This guy in here. Let's click OK. And now we can go over to. It would be great if I was in the design. Oh, now I might want to go back to simulation. Oh, that is inconvenient. Give me a moment. And that is not good. Yeah. Oh, there we go. We're back in here. I thought I had lost this. Now we can finish the sketch, but oh, there we go. All right, so we can extrude all of these guys. Boom. At least we learn a lot. Well, I forgot that fillet, but that is okay. Let me just orbit for a little bit. Let's escape. Boom. We're gonna actually drag it like that. As you can see, red means that we're removing material, and we'll go here, OK, and finish simplify. Boom. So just let's see what happens when I put finish results. And we've got our shape in here, so we're gonna try one last thing. We're gonna create a new study using, yes, create study. Using this guy as our example. Constraints, we're gonna select as usual. Alright, okay. Loads, I'll select, I want to select that face. Great. Smooth, 90 degrees again. 100, okay. We'll do the same thing over. So you can see it's much quicker than Solidworks as well. So I'm beginning to like this interface a lot more. Was that 100? Boom. Let's pre-check all information is required. All right. Boom. Let's solve. So we're just doing a static string. Oh yeah, that's what we're doing. Yeah, there we go. See, wait a minute or two until we see how this looks like. By the way, this piece looks a lot nicer than the one we had in SolidWorks. Actually, really quite optimized the overall weight that we had in here. So let's take a look. All right, let's close. Oh wow, that is. All right, this is the safety factor. So now we got a minimum safety factor 6.5 there. That's quite all right. So we got the stress. All right, quite reasonable. We begin to see a little bit more turquoise in here, like that aqua color, which is again as a result of adding these sudden changes in geometry that create the stress concentrations. What happens if I click on finish results? I'm probably that is quite good. Well, you can probably export this geometry and just use it for whatever you want it. Let me just like save in here. Oh, we can just again double click on results. Result tool. Oh, we can animate real quick. Let's take a look. That's very nice. You see how the stress is changing at that point in real time. Wow, I like it. Compare and spec, select. That seems quite alright. I guess I would use this piece. Let's see what if I go back to design. Well, it didn't save. Let's see whether. One moment. Back here. All right, folks. Well, I just discovered something very, very interesting that we can now see in here is that earlier we couldn't see like these pin contours in our design module. And the reason for that is if we go back to simulation, we go over here to where it says shape optimization to results, just click in there, and we go over to promote. Originally, we had said that we wanted it to go over to the existing simulation model. But now, if we wanted to go to the design module, we just had to click in design workspace. And that way, all of the modifications that you would later do, they would appear there. And there, when you save your file, that's gonna be all right. Just notice that when here we can see, let me just move our arrow in here, how does the mass ratio goes changing as we move the arrow over there. And now that, well, we have done this simulation correct, let's go to our aileron bracket. And we're gonna do some fun stuff with this one here. And in fact, I already began. I just did I didn't begin, I just clicked in shape optimization. Let's begin by specifying the material. And a way to do that is in here. We go here to where it says edit. You can just go all through Fusion's library, or otherwise you can create your own material already. And we can go here for titanium, and we can call it, yeah, we can just do it like that. We can just do it as, okay, and you see it changes the color, but not our constraints will be that this guy and that guy will be fixed as usual. And then we're gonna do a couple of load cases, one where we're pulling like that, one where we're pulling upwards, one where we are pulling backwards, and one, yeah, like all 4 cases. So to do that, we're gonna apply a load. Over here, yeah, we can begin with that case. Again, we'll do 100 newtons. And we're gonna new load case. Load case number 2, let me just specify this guy in here. And modify that. Just gonna move the arrow 90 degrees like that. Boom. We're gonna do that 2 more times to account for all 4 90 degrees of the circle. Give me 1 moment. Oh, let me see. Okay. Oh. There we go. Back again. I'm gonna clone load case. Boom. You need to click on that little hole so that the software knows that we're using it. We're looking at that load case. We go back and loads. The constraint is the same, by the way. Yeah, we're kind of neglecting gravity. Boom. 180. There we go. Okay, and one last time. Boom. Boom. There we go. I believe we need 190 degrees. We got that load case. Alright, I think we are good. Just let me know. And then as for the mesh, oh, I didn't actually specify the mesh. So I might need, oh no, actually it works for all of them. I'm gonna go here. No, not yet. I wanna first mesh, go to the mesh settings. Oh, we're just gonna go like that. Okay. Yeah, let's generate the mesh. How do I do anything? I'm gonna use the preserved region that I didn't actually use it before. I'm gonna go back again there, back again. There we go, one center. Oh, it's not really the edge that I want to preserve. Oh, yeah, maybe. There we go. Center, yeah. Let's see. Oh, I see. Yeah, I think 6. Let's make it 5. And there. Boom. Why doesn't let us select that other face? Alright, we can preserve again. Boom, like that. 5 millimeters as well. We'll do the same thing in here, so that at least it knows we need to preserve this area. Oh. 5 millimeters as well. Let's take a look at ship optimization criteria. Well, it's the same thing that we had before. I'm gonna go for 40%. Yeah, okay. There's your plane. Alright. Let's make sure we got all the required information. So, yeah, let's actually solve. Let's see what this looks like. Oh, cloud credits, right? Boom. Solve one study. There we go. Let's wait a moment and see what it does. Let's see. Hopefully it will be a little bit better than the Y bracket that we had before. All right, so let's see how this looks like. Oh, very interesting. Wow, this is definitely very interesting. So part of the, we can do like we did before, where we can, like, again, the reason why it managed to preserve 30% of this shape is because we had all of these necessary pieces in here, but what if I also made it, if we also wanted to preserve all of those faces? Maybe we're gonna try that in a moment. This looks pretty good, I would say. Yeah, it managed to save quite a lot of mesh. Wow. Very interesting. There's already 60% of the mesh. Wow. Your target was about there. Very cool. Before actually, I might run another simulation again, where let's see whether I can do that real quick. Can I copy that? No. Then I might need to add another preserve region and run it again just to see whether this might look a little bit better. As when it's my mouse, it's connected again, which it should be now. Give me one moment. There we go. Alright. I'll click on finish results. Let's see. I'm gonna copy this study real quick. Go here. Click on clone study. And we're gonna add a optimization. Let's see whether this mouse wants to work. Now, my magic mouse wants to work. Let's preserve region. Yeah, I wanna. Yeah, that. No, region. Let's do 5 millimeters as we were doing before. Oh no, I don't. Oh no. I want that face. Interesting. I just I think I want this to go towards the inside. Foundation. Let's see. There you go. Can I edit that? Let's see. That kind of, there we go. There we go. Interesting. Let's continue preserving. Interesting. It's not as good as the Solidworks interface. Actually, like a quick limitation there. Oh, well, that is fine. I guess we're gonna leave it like that. It's not the end of the world. It's not the end of the world, definitely not the end of the world. Yeah, I guess. Hold on a moment. Oh, where did it go? Yeah, that is interesting. I'm still let me see if I can modify that box in there. Once again. Yeah, this freaking mouse is. Let's see. I want to leave it like that, but I guess you could modify those numbers as one would please. But let's see whether this would change a little bit the design. How much different would it be, given it has the same objectives? Well, let's see. Interesting. Huh. Yeah, again, the more information that you can provide the software, the better the simulations will be. Like the actual end results will be. I guess this is quite okay anyways. I want to look at, actually, that's okay. Let's do, we could probably promote this thing, and we can, yes, send it to the workspace. But this is where we have it. So I might leave that bracket as it is and just change these guys. I'm gonna go like that. Just change it. Do something like this. Boom. Yeah, that sounds cool. Boom. Now I might want to do a couple of fillets there. Oh, that's too big. Two, 3, 4, 5, 1. Oh, well, that's quite reasonable. And then let's actually go to the solid. Boom, it's 2. Cut. I like it, just to make sure that it actually. Oh, let's actually move this around. Boom, like that. That should be okay. We'll also just go here to view. No. We can actually go here to bodies. Boom. We can hide. Alright, that's how it would look like. And here we wanted to keep that shape as it is. We can do a quick simulation of this guy. Yeah, finish results. That's how we got it. Well, the new simulation study, just to make sure that everything is okay. So just bear with me one last time. Yeah, you can see our pieces completely updated. Oh no, I don't. I haven't done anything yet. Let's make sure we were using titanium before. Let's just make sure that that is the case. Yes. Constraints, those guys are fixed. Oh, and one thing to mention is that like when we did our simulation for the topology optimization, it actually took into consideration all 4 load cases, which is no small feat. And here we're just gonna make, for simplicity, just one load case, but that is just like one thing to have in mind. Oh yeah, we can just do that. Boom. Let's just pre-check. Everything is okay. Yeah, let's just solve. It should be rather quick, this thing. Just take a look at the stress and all those fun things. All right, let's close in here. Oh, well, that is very interesting. We see it's still a somewhat, yeah, that looks like an out of plane stress. It's not a completely planar stress situation here, particularly over there. But again, that is an exaggeration. I would want to look at the safety factor, which is, oh wow, number 9. I want to look at the stress. And yes, again, most of this is blue, which is no surprise. Again, only at the holes you see some yellow, and that would stand for just a sudden change in geometry. Just to finish out things today, we're just gonna do a quick. We just want to look at a quick animation. Oh yeah, let's play this thing. You can see how these numbers go changing as minimum. Wow. All right. But yeah, so there we go. This was a quick introduction to topology optimization. I hope you found this very useful, and I'll see you next time. Bye bye. I just wanted to show you one last way in which you can perform topology optimization. And as you can see, we are in a new software right now, and this is Ansys. This is precisely the workbench in Ansys. And it's actually rather easy to use, and it's not very design based, it's more analysis based, and I think that's where most of its power relies. So we're still going to use our Solidworks file, which we saved as a step file. I'll show you in a moment. And we're going to begin with a static structural analysis. So we'll click there and we'll just drag it over to a grid window, which is, we might want to zoom in like that. There we go. And when it says geometry, we're going to right click in there, import geometry. And well, I already have it like that, the white bracket dot step. That's how you should save it in SolidWorks. I'm going to give it like that. But before we proceed, let's go to engineering data. So we'll just right click in there and go here to edit. So by default, we're going to use structural steel as our material, but if you wanted to change anything, right, you can go here to where it says engineering data sources, and then, for instance, click in general materials, and you see all of these guys will begin showing up. You can go composite materials, and see even more showing up, and well, depending on what you want, you can click on that plus button in there, and it's going to add it towards your material. For instance, go here to general materials, and I can go to where it says aluminum alloy, click here and add. Now it's been added, so I can just click again in there and you can see it over there. So we're good. We can close this window. In fact, let me just check the geometry. I usually use design modeler instead of space claim. I believe. Let me see one moment. It is rather messy. Just to check that everything is alright. Yes, it is the design modeler, the one that we always use. So I'm gonna click in here where it says generate. Oh, there we go. This is our piece. It looks exactly like the one we got, and it's much easier to design it in SolidWorks, believe me, than to design it here in Ansys. But much easier. The scale seems reasonable. We can save. Well, no, we won't save this now. Well, let me just go back here to where it says DM. We're just gonna close this module in Ansys, and then we'll proceed over to model. We'll go here to edit, And it's gonna bring that geometry that we just looked right there. And give it a moment. It usually takes a little while. By the way, Ansys has a bunch of modules that one can use and combine. This is a very simple application in here. Now we can close this window in here. Oh, and we go here. We have the M. It's gonna begin loading our piece. I'll give it a moment. What's new? Mechanical? Yeah, I don't really need to know. I just want to go. Well, how do I? Hi, let's see. There we go. Where's our piece is the question. Where is it? Oh, is it? No. Let's see. Something to fit. Yeah, I'm not sure where it is. Maybe it's geometry. Oh, there we go. Oh, I was getting scared that I just couldn't find it. So here we got it. Let's take a look at our geometry. We got our Y bracket, and we can click in there. And then in here, the material, we can change it in here to the one that we had before. So we can go for aluminum alloy. We don't need a bounding box. The statistics, we don't need none of that. Then, yeah, that's what we had according to the system. Mesh. So mesh, we can generate a quick mesh. And it's gonna, yeah, that looks quite awful. So there's, I think, a lot of the power in Ansys relies on being able to control the mesh. So for instance, I can select this edge in here, like that. I should keep the control button pressed. I go like that, one, boom. I'm gonna hit all of those edges. I'm gonna do the same thing on the other side. Let me just change it. There we go. Click. So we're clicking escape. Oh no. Oh, I should not have done that. Should get clicked again in here. That doesn't matter. I'll do it again. Yeah, it's a little bit tedious, but you'll see there's a bunch of things that if you want to learn more about how to mesh in Ansys, I strongly recommend watching a couple of good YouTube videos. I personally learned how to use Ansys applied for CFD, not for structural mechanics. But it still does the job. Like a good meshing, it's the key for success. I would say. I'll just keep on the control button on. Boom. That's the key for success. Exactly that. We just keep on selecting our edges one by one. Yeah, I like this more than in Fusion or in Solidworks, where it's more automatic. You don't have so much control over. Oh, let me just zoom in here. Boom. So you can right click in here. You can go in here and insert sizing. So just click in there. Well, my mouse occasionally dies. There we go. We can click in sizing. And you can see we can do something along the line. We don't want element size. We can say number of divisions. The number of divisions we want, let's say 200. How would that look like? Generally, I like to go for hard. Yeah, maybe 200 is a little bit too much, so we can do 100. They're quite reasonable. I like how it's distributed all around. And then we can click in. Yeah, we got that edge sizing. Maybe we could add a couple of face sizing around here. That way, oh. And maybe if this mouse worked, life would be much easier. It's just to illustrate how this works. Maybe I'm gonna very probably exceed the maximum number because I'm using the academic version of Ansys in here, which I believe caps you at 500,000 elements that you can have in your mesh. Oh, Oh, that is lovely. Come on. Come back to power, my friend. There we go. Just don't forget to continue pressing the control button, otherwise all of these selections will disappear. Let's press the control button. Before, there we go. Boom. There's the way I like it, like that. All right. I'll leave that face in there. There we go. And so we can again go here to insert, maybe also a sizing. And here we're gonna have face sizing. Here it's probably also gonna be element size. Oh no, element size. Again, I don't know, make it. Let's try with 0.1. We can do hard as well. And yeah, so let's go back here to mesh and generate mesh. Let's see how that would look like. It's gonna look a lot more refined, that is for sure. And then you can add like some models where like these mesh elements, you know, they might look like triangles, trapeziums. You can add additional features where you can just specify they don't have to be rectangles, for instance. But that again takes more computational time. As you can see in here, it's gonna take a little while. So if this doesn't stop in the next minute or two, oh, it's about to be done. Oh, I like it. All right, let's see. So we've got a good meshing on in here. Let's take a look at the boundary itself. Yeah, that seems reasonable. Yeah, like at least those are the areas of interest. I like it in there. But first, let's look at sizing. Oh, let's see. Yeah, we need to look at statistics. So we have exactly a little bit less than 500,000 elements, so that is okay. So I think this should work. Might be a little bit too much, but it should work for our purpose. Maybe I'm gonna go back here and I'll make it twice as big. That way, generate mesh. And we can reduce the number of elements and the simulation will ultimately be much faster. Which, yeah, this is just for demonstration purposes. Again, we could have a lot more elements in this phase, but that's fine. We can leave it like this. Not the end of the world. Let's give it a second or two. Quite good. Well, the number of elements didn't quite change. Well, I don't really care. So now we can go to static structural and we're gonna right click in there. We're gonna insert our boundary conditions. So essentially we have a lot more possibilities, which I really like, which gives you an idea of how much Ansys is focused on analysis instead of design. So we can have, for instance, one that I like, for instance, is also cylindrical support. So we can go here, apply, geometry selection, go here to face, like that face in there. Oh, I should actually, let me zoom in a little bit, but it's not allowing me to do that. There we go. No, well, it doesn't matter. I'm gonna hit the control button, that way we can specify all faces. So we got 4. 4 faces, gorgeous. And now we're gonna insert, where's our 4s? And instead of 4s, we're gonna use a bearing load, which might be a little bit more accurate in this case. So we're gonna use it in here. We're gonna use a component. So we wanna do it along the X direction. We want to have 100 newtons. Let's see, does it work? Oh no, maybe I shouldn't put a P in there. There we go. Maybe, oh, I should actually put a negative sign in there. Let's see. There we go. Gorgeous. And now we're gonna do the same on the other side. So we'll go to bearing load. Let me just zoom out for a moment. There we go. Zoom in. Oh, yeah, I should actually pan. Otherwise, it's gonna give us a rough time. There we go. And now we go back here. We'll select that face. We'll select that face. Instead of vector, we're gonna use components. Oh, we didn't actually. Give me one moment. Let's see. Yeah, we want to apply that geometry. And in here we're going to apply our 100 newtons as we did before. There we go. Oh. Just like that. Boom. So now let's just pan away. And yeah, let's begin our simulation from here. Let's see. Give me one moment. So we go here to a solution. We can just click in solve. It's gonna take a little while. Give it a moment. Maybe we could. Oh, yeah, we have exceeded these sizes, so maybe I should change the meshing real quick. As I expected. Well, let's go back to this edge sizing. So, yeah. Let's see, can we update the mesh? We have, but I believe the number of nodes has to also be below 500,000. Let's see whether that's the case. No. Maybe I can go back here to face. Just make it slightly bigger. So we can update mesh. And we can run the solution again because these guys are just left unaffected. And we need to take a look at our statistics before we do that. Oh no. Then in that case, I'll go back to edge sizing. Number of divisions output 40. That's okay. Let's update again. It takes it's a much faster process. The mesh again. All right, that is quite good. So we can go back to solution and solve. So we're gonna proceed. That is very interesting. Well, this looks a lot better. I mean, it's still not perfect, but for some reason, you know, the academic version of Ansys is just a little bit painful to use. There's a couple of limitations I'm not much aware of, but I think this should work. Well, it seems it did work. Oh. Did it work? Did it work? Oh, there we go. And now I had to just literally insert the results that we wanted. We can go back here and insert, for instance, the strain, equivalent mices, variable results. Yes, it looks quite similar to the plots that we were getting on the other softwares that we had. Like again, the blue region. That seems quite similar to the Solidworks numbers we had from earlier. So yeah, if we are happy with this, we can, first things first, I want to save, oh no, I'll save this. I'll leave it here in the getting started with Solidworks. You can see all of these guys. I'm gonna call this one Ansys Y bracket. Oh, there we go, and save it. And now I think I'll pause it here before we continue with topology optimization. Alright folks, we are back again here at the Ansys workbench with our analysis completed in here. So now it's time for us to do the topology optimization. In order to do that, as soon as my mouse gets back to me, again, we're going to drag the module that is located in the left tab, that it's called topology optimization, and we're going to drag it over to this white canvas over here. So give me just one moment until I manage to do that real quick. It's not working, so I'm gonna see where it is in here. I'm gonna left click in there, and where it says, oh wow, why did it create so many? I'm gonna delete all of these guys. I just delete. Yeah, how many did it create? Wow. No, we don't want so many of these. Yeah, it's important to use a good mouse, as you can see, because otherwise it's gonna be creating stuff that one wouldn't want. So the way you would do this, yeah, let's delete, boy. All right. So we go here, topology, and we drag. Oh, come on! You gotta be kidding me. Oh, there we go. All the way here, where it says solution in red. We just bring it there, and we are gonna click in edit. So it's gonna bring us back to where we had our general setup a few moments ago. And all we need to do is just modify a couple of parameters and run a new study. And what's good about this is that it's gonna use the existing geometry, the existing setup that we had before, the existing boundary conditions, of course, as you can see in here. So you can see the static structure from earlier, and then our topology optimization. Let's just take a look at the objective. This is something that is pretty standard here in Ansys. We won't modify this. Response constraint, this is something that we will modify. So this is actually what we're interested in. For instance, the response could be either mass or volume, or you can actually go and tackle the global stress, displacement, reaction force. We'll go for the classic mass, and we are gonna say that we want to retain 60% of this. And we can click in solution, and yes, we want to export our topology afterwards to an STL file. Yeah, I feel we're good. What about this guy? And we might want to insert a topology density tracker. Oh, well, we don't want two of them, so we can delete. This is something that will allow us to see in real time as we are running our simulation how this is changing. And I think this is quite alright. So we can literally click here and solve. Let's go back here. Just gonna begin solving our simulation. So let's see what is it. Oh, was not successful. Remind me later. What is this one? Please bear. Right, folks. Well, the reason why it wasn't working is that after doing a quick Google search, turns out that you don't need to save. You need to save at the last step. So I had to redo everything again, and I just rerun the simulation, and this is what we get. So this is our shape, and now we go to topology density. This is how it looks. We can have in here a quick animation, and we see how that actually varies. But there is something that we're not doing correctly, which is we are not preserving some things. That's why we get this awkward shape. So let's see whether we can change that again. So an optimization region, maybe, well, we might want to do a selection over here. Whether we can select one of these faces. Just like that. Maybe this works, I'm not sure. But it's interesting. It doesn't take so long to run, which is also a positive aspect of the Ansys software over here. I'll consider that a big plus. There we go. Boom, boom, boom. Yeah, I believe that is quite alright. Well, we can click here, apply. About 21 faces. That seems reasonable, and we can just rerun this whole thing again and maybe get some more interesting results. We're gonna leave everything again as it was. Response constraint, mass retain 50, that's okay. And so let's solve. Let's see, what does this do? Alright. Let's see. Topology density. Oh, that is looking much better. Interestingly, that is 50% of the mass less. So I wonder whether we can decrease it even more. I have solution information here. Look at the conversions. What is the density? Wow. This is very good. Let's see whether we can change the response constraint. Mass retain 30. Boy, let's rerun this thing and let's see whether it can give us even better results. Let's see, topology density. Boom. Alright, that is pretty good. It's beginning to look a lot. I guess this is very similar or somewhere in between what Solidworks gave us at the beginning and then Fusion 360 later. And I'm actually quite a fan. I like this shape. Yeah, so these are marginal areas, and yeah, we should keep all of the gray stuff. All right, we can close this window in here, and now when we click in solution, let me see 1 second. All right, so we are back here at the Ansys workbench, and where it says results, we're gonna right click in there and transfer to design validation system. So it's gonna take us to a new static structural analysis. So we're gonna look at that right now. And let's see, give it a moment, give it a tiny bit. Well, one of the things I don't like about Ansys is that it's gonna be a little bit hard to bring this geometry out of here. So first I'm gonna click in here and I'm gonna click on update. Well, I should have done that in geometry as well, but let's give it a moment. Oh, this guy is loading. Oh. Well, I'm not sure why this just happened. Alright, there we go. Oh, here the geometry, and we can just click also update in there. we can, once it's done updating this thing, we can edit the geometry and see how that looks like. But let's give it a second. The thing is that, like, I don't like editing geometry in Ansys. It's not a software made for design. It's a software made for analysis. Let's see what's the best we can do in here. Oh, I usually use design modeler, so let's see how that. I don't like space claim, so let's see design modeler how that will look like in here. Yeah, maybe you will need to generate this thing. But yeah, I guess I'll show you as well once my mouse comes back to power what the design modeler, or what the space claim looks like. Yeah, this is not okay. I think we're gonna, yeah, let's close this guy. We probably, in a moment. Yeah, okay, no worries. Let's see. Huh, interesting. Where's our... I thought I had imported our geometry. That is interesting. Huh. That's very interesting. I didn't do that. All right, here we go. This is what we wanted to see. So this is very similar to what we had in Solidworks and also in Fusion. We can see our original piece, and then below it, the actual piece. If I go to System 1, I can even, suppress that, and we can leave this guy in here. Let's just spin this guy around a little bit. There we go. And there's a bunch of different things that we can do in here. But if you're just lazy like me, you can just use this piece as it is in here. There we go. Here's a way of smoothing out our surfaces. Yeah, that looks pretty good, I would say. But yeah, I guess this is fine. So we can close this and go back to our model. So let's edit that. Yeah, okay, yes. And we're going to delete that as usual. Yeah, so we have the whole... Oh, I see. This is interesting. Oh, I might want to delete this guy directly. That might make things a little bit interesting. Yeah, all right, yes. This is yes. Now let's see whether we have imported the right geometry, and it seems we haven't. Huh. Very interesting. Yeah, all right, well, what is going on? Our objects may have lost some score. All right. Well, I think we managed to fix what was going on in here. So now we got our updated geometry, which doesn't look that good in here because it wasn't smoothed out. But I was just afraid, as you could see from the very quick video earlier, that like I would lose those surfaces, which we need to modify again, because the bearing, we have one bearing node, so I'm gonna choose, see if it even allows us like that face. Yeah, you see it's a little bit not good. So I wonder whether I can continue modifying these guys. Yeah, so I think I'll stop it here and I'll be back with more. Alright folks, welcome back. I apologize for keeping you waiting in here, but I realized I was committing a big mistake. So we're back at the this is a space claim, the CAD workspace here in Ansys, and we're gonna first suppress that little guy in there. I don't want it. Then what if I'm gonna say that, yeah, we'll activate this guy for physics, because this is where we're gonna proceed to do all of our calculations. Then in order to smooth out this surface, we can go here to facets, shrink wrap, we can click 1 millimeter, and we're gonna preserve features. That is super important. That's why it wasn't working earlier. So you should see that our little circles are over there, they will be unaffected, I believe. That is the reason why. Indeed, they seem to not be affected, which is good. Alright, yeah, that seems cool. And then we can do the smoothing out in here. For the volume aware, boom. We just click again. Oh. Yeah, I'm not sure whether I'm there we go. Yeah, select face. I'm trying to do select face. Oh, let me just zoom out for a moment and oh boy. There we go. Oh no. Just do like this. Boom. Yeah. Just like that. Yeah, that is essentially it. This is the piece that we'll use. And yeah, if we've done it correctly, we can just close this window and go back to our model. Let's go ahead and edit that. Yes, that is okay. And this is just one last step to validate that our design is actually correct. So I've tried many times before already, and I haven't filmed that because it took me a while, but hopefully now you will understand what are the challenges involved in here. So you just give it a moment until this thing updates itself. So let's see, I'll click in here, it will complain. Yeah, boom, boom, alright, yes, I know. Let's click here on the arrow, so we see this guy. Oh, I realized I didn't do one thing. Let me go back here to geometry. I did not eliminate the old geometry, which I should have done. So let's do that real quick. At least you learn from these mistakes that I'm committing, so that you hopefully in the future won't do them again. At least you see what's happening. So where it says system 1, I'm gonna delete that. Boom. So now we're left with only that guy, and we can just limit that. And now back to the model. Edit. Yes. Perfect. So let's see what this guy is gonna do. It should be a rather quick process. Yeah, I don't want to do that. Close. Let's give this a second for it to update itself. All right, beautiful. That's what I want to see. All right, so bearing load. We need to select again our geometry, and if everything is done correctly, unlike before, let's just move it like this. Boom. See, is it possible? There's a question. Oh, let me just go escape. It's not. Well, alright folks, this might be the last time I'm going to interrupt the video. And that is because I was trying to figure out some interesting issues about how Ansys does its optimization, and I think I've figured it out right now. Turns out we were actually doing it quite well. Turns out there's a couple of things. First, in solution, we should have actually where it says, let me go optimization region. In here, optimization region, we want to use topology optimization level set instead of density, which was what we were using before. Then I refined the mesh a little bit to include, you know, on those two holes in there, just did a sizing, divided it, and also the decrease the element size, and this is what we get overall, which looks much better. This is about 50% of the original size. So now we can take all of this geometry back to the space claim area and do a couple of modifications that should, I believe in theory, allow us to select the faces that we want, because again the reason why we couldn't really work is because this face, that face in there, and that face and that face, we just couldn't select them. So let's see whether we can do that. Hopefully I'm waiting for my mouse to, or there we go. So now I'm gonna, this was like maybe the 10th time I've tried doing a simulation, so I'm gonna again go to transfer to design validation system. Hopefully you will learn from all of these mistakes. And again, I'm telling you, Ansys is good for analysis, but not for design. Because all of these issues in Fusion and in Solidworks, they wouldn't have been a problem at all. Because you can select the surfaces and everything is okay. As usual, I'm gonna update there, which is gonna take a little while. I have no idea, a little bit longer than before, given the increased mesh size. Well, not mesh size, I mean just mesh elements that we're using in there. Then we're gonna update the geometry again. Let's give it a moment. Yes, I see. Let me close that window. I should take us back to the workbench. There we go. Still, there we go. Now let's do the same in geometry. Update. Boom. I have faith that this time will work. Otherwise, I think I've tried literally everything. So we'll see how it goes. Just updating that. We go now. Let's go to space claim. Boom. Let's look at that. So it's a lot more complicated to do topology optimization here, but well, it depends on what you're more comfortable with, the tools that you have at your disposal, among other things, you know, price, cost. So right away, I'm gonna suppress physics for that one, and I'm gonna activate for physics, and I'm gonna say this is the optimized design, just to remember what this is. Oh, where's my mouse? Where is my mouse? It disappeared again. I cannot see my mouse. Give me just one moment. Connection lost, I see. There we go, connection again. I wonder where it is. Oh, there we go. Or suppress. There we go. So now we're just looking at this. So in theory, we should be able to select the inner. Yeah, all right. Then we have our facets. Beautiful. Oh. Let's zoom. Oh. There we go. Yeah, select.